Hi, this is a preliminary analysis of the Bluejue Mini at 2426 megahertz. We basically did a 3D spectral characterization where we had only one frequency, the middle Bluetooth channel of 2.426 gigahertz that we were recording. We did our analysis on one Johansen chip antenna that has a part number 2450 Alpha Tango 07 Alpha 0100. And we took that antenna on the board, which we're viewing right here, and we evaluated the antenna in a 3D spectral gain pattern with 10 degrees resolution. We have a theta and phi grid we established, and we calculated radiation efficiency versus frequency, peak gain, and we established some frequency graphs. Okay, the direction of X, Y, and Z in the sample so X is in this direction here. This is X. Y is in this direction here. And Z is straight up from the board this way. Now the antenna, the chip antenna, is on the opposite side of the board over in this area right here. In the anechoic chamber that was used to characterize this, we have a rotator right here. We have fixed the device in the same orientation here, where we had Z coming up this way, X to the left here, and then Y down here. So this was the same orientation we used to do the scans. Here's one more view just to underscore the direction of Z, which is right here in this direction, right cutting through this way, with the receiving antenna over in this area here. It's helpful to know where Z is because that's where the nulls will be found. So after we got everything set up, we have acquired a theta, phi, and decibel power, radiated power, quite a few points to get a 3D spectral plot of the device. And here is our 3D plot of the device after we apply all that data and assemble it. So as you can see, where this is the Z-axis, that's related to the top and bottom of the Mini. And if we rotate around, we have the X-axis here and the Y-axis here. Now, I'm going to rotate this. I know you don't have a full frame here, but if I rotate this, you can see it's a very isotropic, or close to isotropic radiation pattern. The donut, the nulls are very unremarkable on the top, which is very good. On the bottom, they're a little bit more pronounced, but really for a device like this, at the power and the range that you're transmitting at, this is a very, very good result. If we compare this just with a slice, this is of course just one slice through the Z-plane, you can see the nulls here, and they do match top and bottom. This top null here being right up top here, and of course the bottom null right here being right here on the bottom. if we, let's move this out of the way, and let's bring in Johansson's actual data sheet here. By comparison, we can see that it's not all that different. We're cutting through the XY direction here, the XZ, and if I can scroll up a little bit here, we have the YZ cut on the bottom. Maybe I can pull this down. Here we go. We have the YZ cut on the bottom here, and of course this is in two polarities, a vertical and horizontal polarity. That's why there's a difference between the red and the black plots. And returning over to the 3D plot, in conclusion, I would say that if you're looking for an isotropic response, it doesn't get a whole lot better than this. It really doesn't. If you're looking at a directional response, we still have to process some data for the models that in the different wearable positions to make some recommendations. But very, very pleased with these plots on first review.